All right, so today we're going to be talking about another step 2 in factoring, but this is in 3 terms. So last time we talked about 4 terms, this time 3 terms. All right, so what we are going to do is something called the AC method here. Okay, there's actually two ways of factoring trinomials. Okay, first is called the AC method. So first method is called the AC method. Okay, so with the AC method, you're really dealing with the standard form. So let's talk about that. So standard form for trinomial is ax squared plus bx plus c. Okay, so the a is the coefficient of x squared, b is the coefficient of x, and c is the number that stands alone. Okay, and it's always powers from greatest to least. All right, so with that being said, we're now going to talk about the AC method. So step 1 in the AC method is this. We're going to do a times c and also label b. So what's a times c? A times c is taking, let me see here. How do I want to do this? Let's do this. Make it red. Make it red. And then we're going to do this in red and this in red. Okay, and then we are going to mess with this and make it blue. And mess with this and make it blue. Okay, so essentially what we want to do is we want to find two numbers, multiply together to give you the product of AC, and the same two numbers add together to give you the sum of B. Okay, I'll explain when I do an example here. Okay, step 2 is to split. I shouldn't just say that. I should say using the results in step 1, split the middle term, which is bx, okay? And then step 3 is going to be factor by grouping. Okay, so let's show you how this goes. Now, I'm going to do this really quick. I'm going to call this orange and purple. There we go. That'll work better. So that this way we know that it's the same set of numbers that multiply together to give you AC, yet the same set of numbers that add up to give you B. All right, so let's do an example. Okay, so let's take, for example, 3x squared minus 10x plus 7. Okay, so A is equal to 3, B is equal to negative 10, and C is equal to 7. Okay, so what I want to do is so step 1 is A times C, that's equal to 3 times 7, which is equal to 21. B is equal to negative 10. So what I'm trying to find is two numbers multiply together and add together. That will give you, so two numbers multiply together to give you 21. but yet add together to give you negative 10. So if as 21, the A times C gets bigger and bigger and bigger, what we want to try to do is, and we can't find those numbers, what we can do is just do, okay, I got 21, I want to find factors of 21. And it's going to be 1 times 21, 3 times 7, okay? So now we can look at it that way and say, okay, so I know that B is negative 10, and to multiply two numbers to give you 21, I have two choices, right? I can either have positive times positive or negative times negative, right? To get you positive 21. Both ways will work, right? So once I find the factors of 21, I know that these two numbers either have to be positive, both positive or both negative, but since I want the sum to be negative 10, I know that these has to be negatives. And if you notice, what happens is that you see the result right there, okay? That will multiply together to give you positive 21, but yet add together to give you negative 10. So again, negative 3 times negative 7 gives you positive 21, but negative 3 plus negative 7 gives you a negative 10, which is exactly what I want. So in other words, my numbers here is going to be negative 3 and negative 7. There we go, okay? So what's step 2? So this is step 1. What's step 2? Step 2 says to split the middle term. So using the results in, so here's my results though, okay? Is a negative 3, negative 7. Use this result in step 1, split the middle term. So I'm going to rewrite this here. Okay, and what I'm gonna do is split. So I'm gonna replace this result here with this, okay? So let's take a look what that looks like. So I got 3x squared. Now, this is the part you gotta wanna watch. I got minus 3x minus 7x plus 7, okay? So if you notice that I use those two numbers right there, the only addition part is the x, and the reason for that is because in order for this, what I want to do is basically not change the value of that expression. So I want to make sure that whatever I put here is equal to this, to negative 10x. So negative 3x, negative 7x would add up to negative 10x, okay? So from here, step 3, so this is step 2. And step 3 is to factor by grouping, which is what we learned last time, 4 terms, right? So what I want to do is, step 1 was what? Whoa, right? The first 2 terms, the last 2 terms, I want to separate them. Step 2 in factor by grouping is to factor the left group, factor the right group by itself. So what do I have here? I have a 3x, leaving me with x minus 1. I need a GCF on the second group, which is negative 7. Remember, if the third term is a negative, I want to pull out a negative. Okay, so I'm pulling out a negative 7. And what do I have left? X minus 1. And the question is, what do I have in common? So the third step was to factor the whole thing together. The x minus 1 was in common. What do I have left? The 3x minus 7. And that will be my answer. Okay? So there you go. All right? So those are your 3 steps. So I should probably say this. Erase this and call this step 2. and then call this step 3, okay? So step 1 was AC, step 2 was to split the middle term, step 3 was to do factor by grouping, okay? Now, yes, these are 3 steps as we're going. Now, here's what I want to bring up to you, okay? The other thing to think about is, the other method is called the trial and error is the second way of doing this. So let me see here. What do I want to talk about? How do I want to do this? Okay, so let's do this. So the second method is called trial and error, okay? So if I was to take this and go back to multiplying, what I would have is the x minus 1 times the 3x minus 7. And I would tell you to double distribute, so you had the x times the 3x minus 7. And then you had the negative 1 times the 3x minus 7, okay? And then you would distribute. So I'll have a 3x squared minus 7x minus 3x minus 7. Now notice what happens. Notice how this right here, what we just did, is the same as this, except the negative 3x and the negative 7x just switch positions, right? But still the same thing. But I want you guys to understand something. And when we talked about this, I said that this is the same as foiling, right? So what I said was that this was the first times first, which is this part right here, okay? This right here is the last, so it's this times this. Okay, actually, let me do it this way. This is the first, which is this times this, which is the same as this times this, which got you this, okay? Now, I said that this was the last, which is, last is this times this, which is the same as this times this, which is that, okay? So that's my last, okay? So I just want you guys to understand something really quick still. And this right here is my outer and inner. Oops, that's what I forgot to do. Come on, there we go. This is my outer and inner, which means that is going to be, my outer is this, okay, which is right here, and my inner is these two here, which is these two here, okay? That's what creates that right there, okay? So from there, I usually would combine like terms. So again, 3x squared minus 10x minus 7. So again, this is still my first, this is still my last, and my OI, my outer and inner, combines, okay? So when I'm doing trial and error, okay, so now I'm going backwards. So if I'm doing trial and error, what I want to do is say, okay, I know that with trinomials, I have a product of 2 binomials, right? I have this times this, which would give me the first, okay? And I have this times this, which would give me the last, all right? So what times what would give me 3x squared? Well, there's only one choice, luckily, because 3 is a prime number. So it's a 3x and an x. What times what gives you a negative 7, or just a 7, let's say, okay? So you know it's a 7 and a 1. The question is it a 7 and a 1? Or is it a 1 and a 7, okay? So let's take, for example, that I choose 1 and 7, So in order to see if this is right, what I want to do is take my outer and my inner, meaning I want to multiply my outer. 3x times 7 gives me a 21x. Inner is a 1x. 1 times x is 1x. Can I use 21x and 1x and somehow make negative 10x? And you're going to be like, no. I can get 20. I can get negative 20. I could get negative 22, and I can get positive 22. Okay? So, with that being said, I know that 1 and 7 is not the right thing, so I'm going to try 7 and 1. So I go back to inner and outer. Okay? Outer gives me 3x, inner gives me a 7x. Can I use 7x and 3x to get me a negative 10x? And the answer is yes. How? Only if they are both negative. So in order for the 7x to be negative, the 7 has to be negative. In order for the 3x to be negative, the 1 has to be negative. So then that would be my answer, which is the same as up here, just different positions. This and this means the same thing, okay? All right, so that would be trial and error. If you want to try that, certainly welcome to. The problem is that when the A isn't a prime and a C isn't a prime, okay? So that's where it comes down to issues, all right? Now, yes, there's more steps to remember here. You got 3 steps to remember, but here's the bottom line. If you practice it enough, you're going to get better and better at it, okay? So factoring, especially trinomials, will stay with you for the rest of your math career, okay? So if you're not good with trial and error, it's okay. Not many people are. Most people's brain will be good with this, with the AC method. Some people's brain do work with trial and error, so I'm okay with that. And this is the only way we could learn it back in the day. There was no AC method back in my day. Yes, I'm old. All right, so let's try another one. Let me see here. Let's try something different. Okay, so 8y squared minus 72y plus 160. Okay, so with that being said, so I kept on saying factoring step 1, factoring step 2, right? So there's no, I haven't got to, well, there's none, factoring step 3. So it's just step 1, step 2, that's it, okay? So step 1 was what? GCF. So what I need to do is this. I need to see if there's a GCF. I know the variables are not going to have a GCF because although there's a y squared there and a y there, but look, there's no y here. So if there's not a y in all 3 terms, then there is no GCF for the y's. Okay? So I can only look at the numbers. So let's look at the numbers. 8. What does the 8 break down to? 8 breaks down to 2 times 2 times 2. What does 72 break down to? 72 breaks down to 2 times 2 times 2. Ooh, snuck a 3 in there. 2 times 3 times 3. Okay? And then the question is, what does 160 break down to? Oh boy. So we talked about this, right? If I don't know it, then I can do a factor tree. I know it's 16 times 10 because it ends with 0. So this goes to 4 and 4. This goes to 2 and 5. 2 times 2. 2 times 2. 2 and 5. So this is going to be a 2 times 2 times 2 times 2 times 2 times 5. Okay? So my question is, What do they have that I don't have, right? No, I'm sorry. What's in common in all three? Wow, I'm having issues here. Okay, so what is in common in all three? Okay, so this has three twos. This has three twos, and this has three twos. Okay, there's nothing else that's in common. So this is where I'm buying stuff for the triplets. That's GCF. Okay, so I got 8. 2 times 2 times 2 is 8. So 8 is my GCF. Okay, if I pull 8 out, what do I have left? Look at this. I have nothing else left, right? So that means all I have left is a y squared. Minus, what do I have left here? I got 3 times 3 left. So I have a 9y left. Okay, what do I have left here? Actually, I probably shouldn't use those markers, huh? Not, at least not yellow. There we go. Let's use a different marker. Let's use green. So I don't have anything here, so I have a y squared left. I don't have any, I have 3 times 3 here, so therefore I have a minus y, 9y, sorry. And then over here I have 2 times 2 times 5, which is 20, and no y, okay? So everybody see that? So again, I broke these down to primes, and then see what's in common in all three. Once I know what's in common in all three, then I put down my GCF, and then what's left, okay? And the nice part about breaking down primes is that number-wise, I know what's left. This 8 has nothing left. 72 had 3 times 3, which is 9 left, which is where you got this 9. And the 160 has 2 times 2 times 5, which is 20. So I have a 20 left, okay? Don't forget the y, so I should probably do this as well. Okay, so that way you know that the highlighted green is what I have here, okay? All right, so now I know that, what did I do up here? Oh, I said A is equal to 1, B is equal to -9, and C is equal to 20, right? So typically what I would do is this. I would just go off to the side and say, okay, I got A times C. That's going to equal to 1 times 20, so it's positive 20. B is equal to -9. So now I'm trying to find those two numbers. All right, so let's find those two numbers. All right. So what two numbers multiplied together to give you 20, but yet add together to give you -9? Well, that would be -4 and -5, right? So think about that. -4 times -5 gives you positive 20. -4 plus -5 gives you -9. Okay, so that works. So now I have this. Okay, so what I want to look at is, so the 8 right here, guys, is just can just stand alone and just wait to the very end. Okay, so that has to be part of my answer, but we don't have to keep on carrying it down. So when I split the middle term, I'm just splitting the middle term here in terms of what's left. So I'm going to have a y squared minus 4y minus 5y plus 20. And then I got 4 terms, so I split it down the middle. I got to do the GCF on the first group, which is a y, leaving me with what? A y minus 4. Got to do a GCF on the second group. Since the third term is negative, I pull a negative, and 5 goes into 5 and 20. So if I pull 5 out, what do I have left? I have a y minus 4. Now, again, this is the place where you might want to double check yourself. So you might want to distribute this y back in to see if you get that. Okay? If you do, then you have the right factor. Okay? Same thing with over here. You might want to distribute this back in and see if you get this. Okay? Now, factor as a whole, I have a y minus 4 left with a y minus 5. Don't forget the 8. Okay? So I can do this right here and take this and put it right there. Okay? For the 8. Actually, undo. Let's draw it better. Okay. So the 8 just comes back down. So that would be my answer right there. And there we go. Okay. All right. Hopefully that helps you. Now, again, for my preference right now for you guys is probably to stick with the AC method until you get down. So again, here is step 1. Actually, really. How do I do this? So this is the GCF, which really what we call step 1. Then this is the step 1 for the trinomial. This is the step 2. And then the step 3. Okay? So there you go. All right, let's try another example here. Okay. So 18x squared minus 18x minus 8, okay? So what you notice is that all 3 of these are even, all right? So you might not need to break them down. So you might be able to say, okay, let's try just 2 as a GCF. If I took out 2, then I have a 9x squared minus 9x minus 4. Is there anything else that can go into 4, 9, and 9? The answer is no. So you actually got the right GCF, okay? So now my A is equal to 9, my B is equal to negative 9, and my C is equal to negative 4. All right, so again, so GCF is done. Now I got A times C, and that's equal to 9 times a negative 4, so that gives me a negative 36. My B is equal to a negative 9. So I'm trying to find 2 numbers. There we go. What 2 numbers are they? So if you're not sure, I can always come down here and go, okay, negative 36 is what I want. So before I do that, I want to do 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6, okay? So in order for me to add 2 numbers to get you negative 9, it means the larger number has to be negative. So that means this is going to be negative. So you notice that every time I multiply any of these lines, I'm going to still get negative 36 when I multiply those, right? Okay, so now I got to figure out which one of these add up to negative 9. Okay, so let me see here. It looks like this right here would give me negative 9. So let's look. So if I multiply these, 3 times negative 12, does that give me negative 36? Yes, it does. And does 3 plus a negative 12 give me a negative 9? Yes, it does. So therefore, that must be my 3 numbers, which would be 3 and negative 12. There we go. Okay, so now I got to take those 2 and split the middle term here. So again, 2 just stays put and comes down, right? So let's go from here. So I got 9x squared plus 3x minus 12x minus 4. Okay? Now you're going to be like, well, could we do it as 9x squared minus 12x plus 3x minus 4? You can. Either way is fine, okay? Like the first method, the first one, you got to remember the third term is negative, so you got to pull a negative. But the second one here might be a strategy that you might want to use, because then the third term isn't negative, so you don't have to worry about pulling out a negative, right? So maybe let's do that. Let's say, okay, I'm going to do it that way, okay? Instead of this way, I'm going to do it this way. So now I got this, so I got 4 terms, so I'm splitting it down the middle. I need to find my GCF in the first group. So the GCF in the first group, what goes in 9 and 12? 3 does, and I got to take out x. What do I have left? I got 3x minus 4. Do I have a GCF in the second group? Nope, but I'm going to at least take out 1. Leave me a 3x minus 4. So third term is not a negative. I don't have to pull a negative. Okay, so what? Now I got factor as a whole. What's in common? What is left? There we go. Okay, and that would be my, not my answer yet. That's now my answer, right? Don't forget that 2 from top to bring it down here. So now that is my answer. There we go. All right. So don't forget to bring the 2 down. All right. Let me see. I did a few examples here. Nope, I did one example. I did trial and error, 2, 3. Okay. All right. Should we do one more? Okay, let's do one more. This is probably the simplest one that you will see. Okay. So let's do another example, but again, this is simpler. So this is x squared minus 4x minus 32. Okay. No GCF because there's no number right here besides a 1. Okay, so there's no GCF there. There's no GCF for the x's because there's no x on the last term. So there's no GCF there. So great, GCF is done. So now my a is equal to, correct, 1. My b is equal to negative 4, and my c is equal to negative 32. So when I do a times c, that's going to equal to negative 32. And my b is equal to negative 4. Okay. All right, so now I got to find those 2 numbers. Okay. So what are those 2 numbers? Well, if I'm not sure, then I'll go down here and go, okay, negative 32. 1 times 32. 2 times 16, 3 does not go in, 4 times 8, okay? Again, you can do this in your calculator, just do 32 divided by 1, divide by 32 divided by 2, 32 divided by 3, 32 divided by 4, 32 divided by 5, 32 divided by 6, right? Until you come back to these numbers here, then you can stop, okay? All right, so those are it. But if I want to add these 2 numbers to give you negative 4, that means the larger number has to be negative. So guess what I just found, right? So these 2 numbers, 4 times negative 8 gives me a negative 32, while 4 plus negative 8 would give me a negative 4. Hey, that's exactly what I wanted. Awesome. So I have 4 and negative 8. Okay? So let's split the middle term. So x squared is going to be plus 4x minus, no, that's exactly what I wanted, minus 8x minus 32. Yes, you can still flip the 4 and the 8. I just figured I'd do the third term being negative here. Strategically speaking, I would say yes, you should do that. All right, so here we go. Boom, boom, boom. Okay. All right, so I gotta find a GCF in the first group. An x, awesome. What do I have left? An x plus 4, awesome. Third term is a negative, I gotta pull a negative. What goes in 8 and 32? 8 does, awesome. So because I pull out the negative, it's gonna flip the signs, x plus 4. Whoa. Okay, so factor as a whole, I got x plus 4. And what do I have left? X minus 8. Okay, now, with that being said, let's see if you guys made it this far into the video. With that being said, here is the key here, okay? So, if you notice so far, let's go back. A is equal to 3, okay? I find these two numbers, and I get to here. A is equal to 8, but when I took out the GCF, A right here in this trinomial is equal to 1, okay? Notice that my two numbers are right there, which is also right there. Everybody see that? Let's go back. Negative 4, negative 5. Negative 4, negative 5. That's before the 8 got pulled out. I mean, that's after the 8 got pulled out, right? But if it wasn't for that 8, then this wouldn't happen because A wouldn't equal to 1. Let me try to get there. Then A wouldn't equal to 1, okay? Where up here, that's not the case because there was no GCF, A is not equal to 1, so therefore this has nothing to do with these two numbers, okay? This example right here, all right, even if we pulled out the 2, all right, my A is still not equal to 1, it's equal to 9, okay? So once we do this, notice that these two numbers are not in here, okay? However, this last one, what's my A? A is equal to 1. Okay, and because A is equal to 1, look at these two numbers, positive 4, negative 8, right? Plus 4 minus 8. Look at this, plus 4 minus 8. So this only works when A is equal to 1. Okay, you could essentially do the first step and go directly to the answer. But it only works when A is equal to 1. Got that? Okay, so you do step 1, you don't have to split the middle term, you can go directly to the answer. All right? Again, it only works for A is equal to 1. Nothing else. A is equal to 1. So let me put this, let's see here. Let's put a nice, nice blue here. This is because of A is equal to 1. Okay? Notice how here A is equal to 1. That's the only reason why. And remember, A is equal to 1 was for this piece right here. That's after I took out that 8. Okay? And only that I took out the 8. So this negative 4, negative 5 that I used. Oops. What did I do? That's what. That negative 4, negative 5 that I use is also the negative 4, negative 5 here. Okay? There we go. All right. So only when A is equal to 1. All right. So the next part. I know this seems like a very long video. I'm sorry. All right, the next part is this. It's still step 2, again. All right, so factoring, let me see what the title was. I want to stay consistent. So it's going to be factoring. Step 2. 2 terms. Okay, so far we've done 4 terms, 3 terms, now 2 terms. Okay, 2 terms are pretty easy. So these are binomials, right? So obviously you have the GCF, which is step 1. Okay, but after that, you have to ask yourself the question. This is all you have to do. Ask yourself the question, is it the difference of 2 perfect squares? Okay? So that's the question you have to ask. Okay? So the word difference means what? It means subtraction. Okay? So I didn't really need to make that small. Okay. All right. And then the word perfect square. What are those? Okay? So let's talk about that. Okay? Perfect squares. So for variables, it's really easy. So essentially with variables, if the power is even, okay, if the power is even, then it's a perfect square. Wow, that looks awful. Okay? All right. So if you look at it, x squared is a perfect square. Why? Because x times x equals x squared. And another reason is that the square root of x squared is equal to x. Okay? So if you look at this statement, there's actually a couple of lessons right in there. Okay? X to the 4th is a perfect square because x squared times x squared gives you x to the 4th. Okay? It's 2 numbers. All right? Which means that the square root of x to the 4th is equal to x squared. Okay? Let's do one more. X to the 6th is a perfect square because I said even powers, right? Why? Because x to the 3rd times x to the 3rd is equal to x to the 6th. Yes, x to the 6th because, it's same base, raised to a power, and I'm multiplying. What do I do with the powers? I add. Don't forget that. This is where people commonly make mistakes. Okay? And the square root of x to the 6th is x to the 3rd. Okay? And I want you to notice the powers. Okay? When I take the square root of it, what happens? It takes half the power. Okay? And if you think of it this way, it takes 2 halves to make a whole. Okay? All right, so that's for variables. How about for numbers? okay? For numbers, so 1 times 1 is equal to 1. So 1 is a perfect square. 2 times 2 is equal to 4. 3 times 3 is equal to 9. 4 times 4 is equal to 16. 5 times 5 is equal to 25. All right? So let's do the same thing here. All right? It's just a little bit shorter because 1 times 1 is equal to 1 because 1 times 1 equals 1. The square root of 1 is equal to 1. And you're like, which one am I taking the square root of? Okay, so let's take a look at the second one. Because the square root of 4 is equal to 2. Because the square root of 9 is equal to 3, right? Now I'll skip all the way to the bottom here because the square root of 25 is equal to 5, okay? So the square root button is going to be important here, right? If you take the square root of something and it comes out evenly, then it's a perfect square. For example, if I was to continue with this list, it'll go, 36, 7 is 49, 8 is 64, 9 is 81, then 100, then 121, then 144, 169, 196, and 225. That's as far as I remember because the square root of it, this would be 15 times 15, okay? Or the square root of 225 is 15, okay? So just remember that if you take the square root of it and it comes out evenly, then I know it is a perfect square. You're wondering why I'm doing this. It's the neatness that I like sometimes. My writing isn't always always neat, but I try to at least keep the notes a little organized. Sometimes it's hard to do. All right, so these are perfect squares. So if I have a subtraction problem between the binomial and they're both perfect squares, then I'm good, okay? So, example. What do I have down as an example here? So, let's say I got c squared minus 64. Okay? All right, so I got to see if c squared is a perfect square, if 64 is a perfect square, and if it's a difference, right? So, yes, it is the difference. So, I used blue. Right? Yep. Did I use bright blue? I did use bright blue. Okay, so this means difference. Subtraction, right? Mm. 64, so you can go and take the square root of 64, and that's equal to 8. And this would be c times c, right? So, therefore, my answer is this. You guys ready? So when we were multiplying two binomials, when did it come down where it became two terms, right? First, it's 2 terms times 2 terms, so I should get 4 terms, and all of a sudden my oi cancels out, right? So when did that happen? It was with conjugates. What were conjugates again? Oh, the same terms, but one was addition and one was subtraction. So what do I put in here? I said c times c gives me the c squared, or the square root of c squared is c, right? So you could say that this is the square root of c squared is equal to c. So there's my c. And the 8 just goes in here. Plus minus. And that would be my answer. Okay? So, let me do a really quick example 2. If I had c squared plus 64, is not factorable. You're like, why? Well, great question. The answer is that is not the difference. Not so is not factorable. Okay? So it has to be subtraction. No matter how you look at it, it has to be subtraction. Then you look at the left side of the subtraction sign, is that a perfect square? You look at the right side of the subtraction sign, is that a perfect square? If the answer is yes, then you're good to go, okay? But some of them might need a little extra work. Let's say 125, let's just use x squared minus 180. Okay, so your first move might be, because you got so excited about these first two problems, you're like, ooh, let me put in the calculator. Let me take the square root of 125. And when you do that, you're like, this doesn't come out. But this is the difference. I should be able to break it down. The part you forgot was step 1, which was GCF. So what can go into 125 and 180? All right. So let's break it down. 125 breaks down to 5 times 5 times 5. That's a weird 5. Okay? 180. Is tough. 180 is what? 9 times 20. So there will be a 3 times 3, that's 9. 20 would be 2 times 2 times 5. So try that on your calculator. Where's my calculator? Oh, my calculator is not here. Okay, I'm going to tell you that is 180. So what's in common? A 5 and a 5, and that's it. So my GCF is going to be a 5, and what's left? Okay, so let's see what's left. I have a 5 times 5 and an x squared, and then this right here. Okay, so I got 5. I'm sorry, not 5. Oh yeah, that's a GCF. I'm taking out the 5. What do I have left? I got the 25 x squared minus 3 times 3 is 9. 9 times 4 is 36. Okay? So that is what is in yellow. Okay? All right. So now look at that. So 25, the square root of 25 would be 5. So this, or sometimes I even say it this way. 25 is 5 times 5. X squared is x times x. 36 is 6 times 6. Oops. I don't know why I put down x. 6 times 6. And then I have a plus and a minus. So with that being said, what do I have? I have a 5x plus 6 and a 5x minus 6. And there we go. Oh! Forgot the 5. Can't forget the 5. There we go. And there we go. Okay. Hopefully that helps. Let me see what else. Oh, this will be my, I know I should do this one too. All right, so another example. I got 2 more examples and we'll call it a day. So 27 x squared y minus 3y. Okay? So GCF, what goes into 3 and 27? Correct, 3 does. And they both have a y, but they don't both have an x. So I have a GCF y, but not the x. Okay? So what do I have left? 3 times what gives me 27? 9 x squared minus 1. Okay? So now I have the 3y. Oops, before I do that. 9 is 3 times 3. X squared is x times x. And Z1 is 1 times 1. So I just need a plus and a minus. So now I have a 3y times 3x plus 1 and a 3x minus 1. There we go. Boom. All right, how's that? All right, the last example. This is a warning. All right, so I have no GCF, but I do know that x to the fourth would be x squared times x squared. And when you take the square root of 4096, you will get 64. So 64 times 64 would give you that. I'm sorry, 64 times 64 would give you 4096. So 1 plus, 1 minus. So like, ooh, that's pretty easy. So you go, okay, I have x squared plus 64 and x squared minus 64. Whew, that was pretty quick. But then I said, you're right, but you're not. And you're like, well, what do you mean that I'm right, but I'm not? You're right, but you're not. And the reason is because of this. You're right. This breaks down to this. However, what do you see here? Is that not the difference of two perfect squares? Aha! So it is. But this is not the difference of two perfect squares. So that one is done. Okay? So this one is done. And this is not done. Okay? So, x squared is x times x. X squared is x times x. 64 is 8 times 8. Plus minus. So now I can say that this is equal to x squared plus 64 times x plus 8 and x minus 8. That, ladies and gentlemen, would be my answer. Got that? All right. So again, I did 2 step 2s here. All right. So the step 1 was GCF, and then we did 3 step 2s. One was 4 terms, which is factor by grouping. One was 3 terms, right, which was the AC method or trial and error. And then the third step 2 was 2 terms. So 4 terms, 3 terms, 2 terms. And this is just asking yourself, is it the difference of 2 perfect squares? So again, you need the subtraction, and you need the left side of the subtraction to be a perfect square, and the right side of the subtraction to be a perfect square, okay? Meaning whatever number of variables I might have on the left or the right, it all has to be perfect squares, especially after I pull out a GCF, okay? So other than that, I hope this helps. If there's any other questions. Oh, so after this part right here, you're going to ask me, well, can I break down the 3x minus 1? And the answer is no, because 3 is not a perfect square, nor is the x, okay? And if I look over here, the 5 is not a perfect square, the x is not a perfect square, 6 is not a perfect square, so no good, okay? Or even here, C is not a perfect square, nor is 8. Okay, so understand that this became an x squared minus 64. That's the reason why I can break it down more, because the x squared is a perfect square and a 64 is a perfect square. Okay, well, I hope this helps you, and if you have any questions, let me know.